Here is the very important section on the unit circle. So, a unit circle basically is just a circle with a radius of 1. That's all it is. But we find a lot of angles and everything from this circle, considering that the radius is 1. So it's going to be very, very useful for us. The equation of this circle is x squared plus y squared equals r squared, or in our case, since r is 1, just equals 1. So in the unit circle, the radian measure of the central angle is equal to the length of the intersected arc. Remember we said that if you wanted to find the angle, you divide the arc length by r. Well, if r is 1, then the angle and the arc length are the same. This is useful for us. You can read through this. I'm going to explain some things further similar to what this says here, but do read through it. And you can look through these pictures. Basically, we've talked about this a little bit, how you could count by, say, pi over 4s, or 45 degrees. So this would be 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and 8 pi over 4, which is 2 pi. Or you can go the other direction, of course, and be negative. The sine function associates with the y-coordinate of P. So let's say we have, let's see, is there a picture? Let's draw a picture. If we have our unit circle, well, that's not too bad. And we have the point P. And I'm going to call the point P X, Y. Okay? Then the sine function is Y. The cosine is X, and this is just on the unit circle with a radius of R. Okay? Later on, we'll deal with R being something other than 1. The tangent function is Y over X. It's kind of hard to see right here. Y over X. The cosecant is, well, it's not the inverse. It's hard to say. I have to say opposite sometime, and it's not really. But it's related to sine, okay? We'll put it that way. So cosecant is 1 over y because sine is y. Cosine is x, and it's related to secant. So secant is 1 over x. Tangent was y over x. Cotangent's related to tangent, and so cotangent is x over y. They're just flipped in those last 3 cases. So for example 1, it says use the figure to find the values of the trig functions at t. So we're going to find, I do believe, all 6 of the trig functions at this particular point. We don't know what the angle is, but that's okay. We just need the point. So first, sine at our point, we'll just call it sine, it's point t, so sine t is the y value. So 1/2. Okay? Cosine is the x value, square root of 3 over 2. Now it starts to get a little bit more intense. Tangent is y over x. Okay, so tangent is the y value 1/2 over the x value, that is square root of 3 over 2. So we need to simplify this. That's 1/2 times, flip and multiply, 2 over root 3. The 2's go away and you get 1 over root 3. Just looking to see if I have extra space. I do. So let's take tangent, put it up here. Okay, so we can't leave it in terms of 1 over square root of 3. Okay, some old dude long time ago decided that it was ugly to put a square root on the bottom. Yes, as far as I know, there is no other reason why you can't have a square root on the bottom of the fraction. But we can't. So what we have to do to get rid of the square root, if you'll remember from algebra, is multiply the top and the bottom by the square root of 3. Square root of 3 over square root of 3 is just 1, so that's legal. 1 times square root of 3 is 3, and square root of 3 times square root of 3 is square root of 9, which is 3. So the tangent of t at this point is square root of 3 over 3. For the last three, cosecant, that's cosine, cosecant is 1 over y. So that's 1 over 1/2. Flip and multiply, this one's not too bad, and we just get 2. Secant is 1 over x. So that's 1 over the square root of 3 over 2. Flip and multiply, and we've got 2 over square root of 3. Again, we can't have the root 3 on the bottom, so that gives us 2 root 3 over 3. And last, cotangent is x, that's root 3 over 2, over y, 1/2. So root 3 over 2 times, flip and multiply, and this one's not too bad, we've just got root 3. So those are the 6 trigonometric functions at that particular point. And pretty soon you'll find out what that point is, or what the angle is, and whatever these are, whatever t is what we'll find are the actual values of that function and that angle. Okay, domain and range of sine and cosine. If you've ever seen the sine and cosine function, they look something like this. So the domain will make sense. Of course, they're going to go to negative infinity and infinity. The range depending on whether this, and this could be sine or cosine, okay, is always from -1 to 1. Unless you change the amplitude, which again we'll look at further on. But this is useful, again, back to the unit circle with a radius of being 1. In one of our labs, you're going to see how these relate more. Tangent and the secant functions. So tangent and cotangent looks something like this, except cotangent goes the other way. So the range in these is infinity to infinity. Cosecant and secant look something like this. So the range for cosecant and secant goes from infinity to -1 and then from 1 to infinity. The domain, depending, well, for tangent and secant, is everything except for odd multiples of pi over 2, meaning pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, and so forth. The cotangent and cosecant, cotangent looks, that's not quite right. Oh boy, I cannot draw this the other way. This is really bad. Oh, there we go. Okay, so there's cotangent. Its range is infinity to negative infinity to infinity. And cosecant is similar to secant. Of course, I'm not drawing these exact, so, but you'll get the idea. Its range is also from negative infinity to -1, and then -1 to infinity. The domain of both of these is all real numbers except for odd multiples of pi. So 1 pi, 3 pi, 5 pi, pi, -3 pi, so forth. Okay, so we'll look more at the actual graphs of these later on. For example 2, it says, find the point associated with pi over 4 on the unit circle. Okay, so here's our picture with the angle pi over 4 drawn. It's just this angle right here. And what we're going to do is I'm going to just bring this point straight down and then over from the center of the circle, and we're going to end up with a right triangle where this angle here is pi over 4. And what this is asking us to do is to find the x value and the y value. If we find the x and y value, then we've found the point here. We know, since this is on the unit circle, that the radius is 1. So the hypotenuse, look back over on the circle, of this triangle is 1. Since this angle is pi over 4, then this angle is also pi over 4. Remember, pi over 4 is 45 degrees. And so if that angle is 45 degrees and this angle is 90, 90 minus 45 makes the other angle 90, or 45, excuse me. So this is a 45, 45, 90 angle, triangle. That means that x and y are going to be the same. Remember way back from geometry or one of your math classes in high school, if a triangle was isosceles, the base angles were also congruent, and vice versa. If the base angles were congruent, then you have an isosceles triangle. That's what we're talking about here. Now, since this is a right triangle, we can use the Pythagorean theorem, x squared plus y squared equals r squared. and find x and y. And why is it easier for us to find x and y? Because x and y are equal. So we can plug in x for y. And r is 1, so r squared is 1. So all we've got is 2x squared equals 1. X squared equals 1/2. Take the square root, and we have, and since we're dealing with the positive axis here, then we're just going to do a positive answer. We'll take the square root of 1/2. That gives us, square root of 1 is 1 over the square root of 2. And of course, we have to rationalize the denominator. Get rid of the square root. And so we've got square root of 2 over 2. So the x value of this point is square root of 2 over 2. If the x value and the y value are the same, then guess what? The y value is also square root of 2 over 2. So that's one example of how you find a point associated with an angle. Example 3 says find cosecant of pi over 4. So we've just found this point of square root of 2 over 2, square root of 2 over 2. And if you'll remember, cosecant is 1 over y. So we put 1 over root 2 over 2. Flip and multiply, and we'll get 2 over root 2, which we have to rationalize. So it becomes 2 root 2 over 2, which we can actually simplify to just be root 2. So the cosecant of pi over 4, forgot my pi over 4 up here, is the square root of 2. Next, we're asked to find the secant of pi over 4. That's 1 over x. X is root 2 over 2. So it's actually the same thing as before. The secant of pi over 4 is just the square root of 2. And part C asks us to find the cotangent of pi over 4. Cotangent is x over y. So that's the square root of 2 over 2 divided by the square root of 2 over 2. Guess what? That's just 1. So here are the trig functions at pi over 4. And here's a picture of a unit circle. We'll talk about that more in a minute. Let's go ahead and go back and talk about it. So I'll probably create a separate video to talk more about how the unit circle is generated. You're going to be doing a lab, if you haven't already, that is going to talk about, going to walk you through how the unit circle is generated. So just barely touching on it here. We've already talked about how you can have 1 pi over 4, 2 pi over 4, 3 pi over 4, and so forth. And we talked in a previous section about how you can go by pi over 6s. 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 4, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, which doesn't reduce, and so forth. We've just found the point associated with pi over 4. Now, if you'll notice, if you'll come just over to the left here, the point associated with 3 pi over 4 is very similar. It's actually got the same x and y except for the x is negative, which makes sense because that's the negative x-axis. If you come down from pi over 4, the point has a positive x and a negative y because it's the negative y-axis. And then if you just come over here to 5 pi over 4, you can see, because we're negative x and negative y there, that the x and y are both negative. But in each case of the pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, we still are dealing with root 2 over 2, root 2 over 2. If you look at pi over 6, we've got root 3 over 2, 1/2. That's the point associated with pi over 6. Come over here, same deal except for x is negative. Come down, same deal except for y is negative. Over here, same deal except for x and y are negative. And then at pi over 3, notice it's the same thing as pi over 6 except for switched. Well, not the same thing, but they're switched. The x and y are switched. Which makes sense because here you have a 30, 60, 90 triangle. And here you have a 30, 60, 90 triangle. Just in 2 different spots. And then again, things match up just as we talked about for the other 2. So that's a quick introduction to the unit circle. For example 4, it says, identify the ordered pair that corresponds to this number. So we're looking at 5 pi over 3. So where is 5 pi over 3? Here it is. Right there. It is the point 1/2 negative root 3 over 2. And then it tells us to find sine of t, which is 5 pi over 3, and find secant of 5 pi over 3. And we'll do that just like we have before. Sine is the y value, and the y value at this point is negative root 3 over 2. So sine of 5 pi over 3 is negative root 3 over 2. The secant is 1 over x. So that's 1 over the x value, which is 1/2. Flip and multiply, we get 2. So that means that the secant of 5 pi over 3 is 2. You can find all 6 trig functions of any point along the unit circle just using your identities. Part B wants us to do one more. It says identify the ordered pair that goes with negative 5 pi over 6. Oh, so this one's negative. We've got to go in a different direction. So we can't just pick it up from here. But 5 pi over 6, 1 pi over 6. Let's use a different color. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 is right here. So the point with 5 pi over 6 is negative root 3 over 2, negative 1/2. You can also, sometimes I'll just draw this. If I don't have a unit circle in front of me, I'll start thinking, okay, I'm starting at the positive x-axis. 1, 2, 3, 4, 5. Okay, so that is negative 5 pi over 6 right there. And that point is the same, if you'll notice, as 7 pi over 6. If we went that direction. And we'll talk more about how that's important in the future too. So it asks us to find the cosine of t, which is negative 5 pi over 6. Cosine is your x value. So the x value is negative root 3 over 2. So the cosine of negative 5 pi over 6 is negative root 3 over 2. And the tangent of t, or let's say of negative 5 pi over 6, is, I did cotangent on my paper. Okay, y over x. The y value is negative 1/2. The x value is negative root 3 over 2. So negative, negative, we got positive. So 1/2 times 2 over root 3. The 2's go away. So we have 1 root over root 3. Multiply the top and bottom by root 3. Root 3 over 3. So the tangent of negative 5 pi over 6 is the square root of 3 over 3. Let's look at just a few more things here. Even and odd functions. Okay, you'll be able to see this more as we look at the actual graphs of these guys. But the cosine of negative t is the same as the cosine of t. Why is that? Let's draw a quick picture here. Cosine looks like this. So if you have the cosine of a negative point, that would be negative pi over 2. The cosine is the cosine of negative pi over 2 would be 0. And the cosine of pi over 2 is 0. That's why we can say that the cosine of negative t is equal to the cosine of t. Okay? Sine looks like this. Not exactly, of course. So if you've got here negative pi is 0. Here that's not a very good example. I shouldn't have used 0. Here, negative pi over 2 is negative 1, and pi over 2 is positive 1. So whatever you've got, if you've got negative pi over 2, then you get a negative sign for your answer. So that's a little bit of an explanation about why the even and odd functions are the way they are. Cosecant goes along with sine, secant goes along with cosine, so they're the same deal. With tangent, the tangent of negative t is negative tangent of t, and cotangent of negative t is negative cotangent of t. So cosine and secant are the only ones where if you take the trig function of the negative value, you get a positive. So example 5 asks us to find the value of each trig function. So using our property, the secant of negative pi over 4 is the same as the secant of positive, or is positive the secant of pi over 4. Okay, so we can just take our 1 over x for pi over 4, or go back to our list. Actually, the secant of pi over 4 is root 2, so it's just positive root 2. While the sine of negative pi over 4 is equal to negative the sine of positive pi over 4. Since the pi over 4 is, sine of pi over 4 is square root of 2 over 2, then we just make it negative because it's negative of the sine of pi over 4. And last for this section, how do you use a calculator? You just press sine and cosine and tangent, making sure you use parentheses. So sine of pi over 4, you can practice this in your calculator. Just put in pi divided by 4 like this. And you should get 0.7071. Now what if you don't? Well, that's because your mode is wrong. So you may need, does it point that out here? Yeah. You may need to change your mode depending on whether you're dealing with degrees or radians. In this case, we're dealing with radians. If it doesn't have a little degree, it's not a degree. And therefore it's a radian. To change your mode, you press mode on the calculator and just switch it from degrees to radians. And then when you press sine of pi over 4, you should get 0.7071. And then for cosecant is the same as 1 over sine. So cosecant is the same as 1 over the sine of 1.5. So we would put that in the calculator as 1 divided by the sine of 1.5, like this. And you should get 1.0025. And that concludes our lesson so far on the unit circle.